Let us now solve problem number 4. A 12-meter long rectangular reinforced concrete beam is simply supported at its ends. The beam is provided with an additional support at the midspan. So, ito daw yung beam natin. The beam is reinforced with 25 mm diameter bars, 4 bars at the tension side, and 2 bars at the compression side. Concrete strength is equal to 30 megapascal. The steel yield strength is equal to 415 megapascal. And we have a given of raw max which is equal to 0.0157. We are tasked to determine the value of the factored uniform load that the beam could carry using NSCP 2015 provision. So meaning to say factored load, kaya naka-subscript U tayo. Meaning to say, yung hahanapin nating value ng W, naka-ultimate na siya. So for that, para mahanap natin yung value ng W natin, we need to know yung maximum moment natin. So, yung maximum moment natin dito, equate natin siya dun sa ultimate design moment capacity ng beam natin. So, paano natin malalaman yung value ng MU natin? So, by means of finding yung design strength niya using mga formulas natin sa DRB. So, bago tayo mag-proceed sa pagkuha ng maximum na yun, so let us check muna if real DRB yan. Sir, paano po natin i-check kung DRB ba yan or hindi? So, hanapin muna natin yung raw actual natin and we're going to compare that to the value ng raw max natin. So, kunin muna natin yung AS natin. So, meron tayong 4 na piraso na 25 mm squared. 25 mm diameter. So, you have 625 pi. Doon naman sa area ng bakal natin sa compression side, meron tayong 2 piraso ng bakal na merong diameter na 25 mm. So, we have a value of 312.5 pi. So, in checking for DRB, kunin muna natin yung raw actual. That is AS over DB. So, yung AS natin, that is 625 pi over yung B natin, that is 300. We have an effective depth of 380. So, you have a value of your raw, which is equal to 0.01722. So, kung i-compare natin siya to the given raw max, this is greater than to the value of your raw max. Therefore, doubly reinforced beam tayo. So for the next procedure, we will going to assume that using C is equals to T, we're going to assume that compression steel will yield. So when compression steel bars will yield the value of your Fs prime, that is equal to the value of your Fy. So C is equals to T, so mangyayari C sub 1 plus C sub 2 is equals to T. So, yung mga formulas natin dito, yung C sub 1 natin, that is yung sa singly reinforced beam natin na 0.85 F prime C AB plus yung C2 natin due to the compression bars, that is AS prime, FS prime. Kaso nga lang, we assume na nag-yield yung bakal natin. So, that is Fy is equals to AS. So, kapag DRB, automatically, na mag-yield yung bakal natin sa tension. So later check natin kung mag-yield ba talaga yung bakal natin sa tension at saka sa compression steel bars. So if you're going to substitute yung mga given natin, so we have an F prime C of 30 megapascal. Yung A natin, ito yung hinahanap natin. Yung B natin, that is 300. The value of your AS prime, that is 312.5 pi multiplied by Fy na 415. Is equals to 625 pi. That is the value of your AS multiplied by Fy na 415. So the value of your A is now equal to 53.258 mm. So para ma-compute natin yung value ng C natin, we need the value of your beta. Since NSCP 2015 yung ginagamit natin, yung limiting value natin for that is 28 megapascal. Since yung actual compressive strength natin is greater than to the limiting value, we're going to use this formula. So, 30. So, yung actual natin minus 28, yung limiting value natin, over 7. So, the value of your beta is now equal to 0.01722. 0.836. So, makukuha na natin yung value ng C natin. All we need to do is divide the value of your A to beta. So, we will have a value of 63.706. So, for the next step, meron na tayong value ng A at saka C. So, we will going to check if assumption is correct. Sir, paano po natin i-check yung assumption na yan? We will going to calculate for the value of your Fs and for the value of your Fs prime. So, for the Fs, that is 600. So, D, we have an effective depth of 318 minus yung C natin na 63.706 over yung C natin na 63.706. So, we have a value which is equal to 2,978.94 megapascal, which is greater than to the value of your Fy na 415 megapascal. Therefore, tension still yields. Next naman, for the Fs prime, we have 600C, 63.706 minus yung D prime natin. From the center of your compressive steel bars reinforcement to the outermost fiber nung beam natin in compression, we have 70 over 63.706. So, you have a value of, so, eto negative yan, di ba? Negative 59.279 megapascal. So, negative pa yung value natin. Definitely, that is less than to the value of your Fy. Meaning to say, your assumption is incorrect. Meaning to say, your compression steel bars doesn't yield. So, kung mali yung assumption mo, recompute tayo. If you are going to recompute, go back to step number 2. So, by this time, magsi-C is equals to T na tayo. Pero yung value ng Fs prime natin, that is equal to 600 C minus D prime over C. Okay? So, with that, so, yung C1 natin, same lang naman yung approach natin dito. Kaso nga lang, yung A natin dito, mangyayari niyan is A is equals to beta C. So, if we will going to substitute yung mga values natin, you have 0.85. Yung F prime C natin, that is 30. Yung A natin, that will be, so yung beta natin, we have 0.836C multiplied by the value of your B na 300. Plus, yung AS prime natin na 312.5 pi multiplied by yung Fs prime natin. So, ito yung gagamitin natin na value ng Fs prime. So, you have 600 C minus D prime over C is equals to AS. So, yung AS na na-compute natin, that is 625 pi multiplied by 415, which is the yielding strength nung ano natin, nung steel natin. So, by shift solve, we can now calculate for the value of your C, which is equal to 99.87 mm. And next, we're going to compute for the height of your compression block, that is beta multiplied by C. So, you will have a value of 834.49 mm. And lastly, we're going to check if our assumption is correct. Paano po natin i-check yan? So, kunin natin yung Fs, kunin natin yung Fs prime. So, Fs, you have 600D minus yung na-compute natin na C na 99.87 over the value of your C na 99.87. So, you have a value of your Fs which is equal to 1,682.97 megapascal. Then, for your Fs prime, you have 600. Yung C natin, 99.87 minus yung D prime natin na 70 over 99.87. So, you have a value of your Fs prime which is equal to 179.45 megapascal. So, titingnan natin dito, this is greater than Fy. So, therefore, tension still yields, and this is less than Fy. Therefore, compression steel bars will not yield. Therefore, yung assumption natin, nung nag-recompute tayo na hindi mag-yield yung compression steel bars is correct. So, meaning to say, eto yung mga values ng C at saka A na gagamitin natin in computing for the value of your ultimate moment capacity. So let us now solve for the value of your ultimate moment capacity. So mu is equals to reduction factor multiplied by nominal moment. So para mahanap natin yung reduction factor natin, tingnan lang natin etong value ng f sub s natin. So yung other way natin sa pagkuha ng reduction factor, so kung titingin tayo dun sa actual stress na nararamdaman ng steel natin. So since yung fs natin dito is greater than to the value natin sa 1,000, therefore, reduction factor is 0.9. So, yung 0.9 yung reduction factor natin, kunin na lang natin yung value ng nominal moment natin. So, that will become C1 multiplied by yung moment arm natin na D minus A over 2 plus C2 multiplied by the moment arm of D minus D prime. So, nominal moment is equals to 0.85. Yung F prime C natin, that is 30. Yung A natin na na-compute is 83.49 multiplied by yung B natin na 300 multiplied by yung D natin na 318 minus 83.49 over 2 plus etong C2 natin na AS prime. So the value of your AS prime is 312.55 multiplied by yung FS prime na nakuha natin na 179.45 multiplied by the moment arm of D minus D prime. So 318 minus 70. So you will have a value of your nominal moment which is equal to 270.66 kilonewton meter. And with that, makukuha na natin yung ultimate moment capacity natin. So 90% or 0.90 of 270.66 kilonewton. So you will have a value of your ultimate moment capacity of 243.59 kilonewton meter. So with that, meron na tayong value ng MU capacity natin. So ngayon, yung principle lang naman natin dito is we will going to equate lang naman yung MU capacity natin. Diba? That must be greater than or equal to the MU maximum. So, eto yung sa loads natin. Tapos, eto using yung design strength natin, strength no beam natin. So, equate lang natin yung capacity ng beam versus dun sa loads na dadalhin ng beam natin. So, with that, wala na tayong problema sa MU natin, wala na tayong problema sa MU max natin. So, gagawin na lang natin is magre-refer tayo dito sa loadings natin. So, mapapansin natin, we have an indeterminate beams. So, meron tayong tatlong support. Support A, B, and C. So, with this, kung titingnan natin yung principle natin, kailangan nating malaman yung mga values natin dito. Diba? May mga reactions tayo dito. Kaso nga lang, since moment lang naman yung pinag-uusapan natin, diba? Di naman nire-require sa problem na hanapin yung mga support reactions natin dyan. So, we're going to use yung 3-moment equation natin dito since we have an indeterminate beam. Using 3-moment equation, so gagawin natin yan is meron tayong tatlong points, yung A, B, at saka C. Kaya nga 3-moment equation, point A, B, and C. So, mapapansin natin at span A, B, C. So, yung MA natin at saka yung MC natin, they are exterior supports. So, yung value ng moment natin dyan is 0. So, magkakaroon lang tayo ng value dyan for MB. And of course, no, sa pagkuha ng natin, ng maximum moment natin, always remember na maximum moment, MU max o yung MU max natin is located at 0 shear. So meaning to say, yung maximum moment natin is located at 0 shear. So sa pagtatansya natin, pwedeng nandirito sa mga points natin yung maximum moment or pwedeng nasa gitna kasi dito tayo magkakaroon ng mga zero shear. Kaso nga lang, based kapag ganito yung figure natin, kapag simply supported beam over yung tatlong support natin, so usually, yung natin dyan talaga, yung maximum moment natin, located siya dito sa gitna. So, dito sa gitna sa atin, sa MP. So, meaning to say, yung MU max natin, located siya sa zero shear, and it happens to be na kapag ganito yung diagram natin or yung loading natin, nasa gitna yung maximum moment natin. So, MB is now equal to yung MU capacity natin. Kasi yung MB natin, that is the value of your MU maximum. So, with that, no, we can now say na meron na tayong value ng MB natin. So sir, ano ngayon yung value ng MV natin? So this will now equal to yung nakuha natin na 243.59 kilonewton meter. So now, let us now calculate using etong formula natin for 3-moment equation. So yung MA L1 plus 2MB L1 plus L2 plus MC L2 plus yung mga natin dito, yung mga factors natin is equals to 0. Since yung MA natin that is 0, 0 na to. And yung MC natin that is 0, so is 0 na lang natin to. Okay? So for this one, matitira na lang yung 2MB natin. So with this naman, 2MB. So nangyayari kasi dito, sa MB natin, meron na tayong value which is equal to 243.59. Plus yung L1 natin, 6, ating L1. Tapos L2 natin, 6. Plus yung 0, 0 plus. Plus, etong natin dito na WU. L1 cube, ating L1 natin na 6 cube over 4. Plus WU, 6 cube over 4 is equals to 0. So with this naman, kung kukunin natin yung WU natin, makukuha natin dyan is negative 54.13 kilonewton meter. So, paano natin yan ipa-positive? So, gagawin natin negative yung value ng MB natin para mag-positive yung WU natin. Sir, bakit po natin na negative yan? Kasi, kung gagawin natin etong beam natin, diba, let's say, hahatiin natin yan. So, meron tayo ditong MB, meron tayo ditong MB. So, yung ginagawa ng MB natin is kino-concave upward niya yung beam natin. Kino-concave, ito naman, kino-concave upward niya. So, by means of 3-moment equation, kapag yung moment mo is kino-concave upward niya or pinapalungkot niya yung beam natin, so, nangyayari is yung value ng moment natin dyan is negative. Kaya, ine-negative natin yan. Regardless na nakuha natin dito is positive. So, yung negative natin dito, ito lang yung orientation natin na nagsasabi na etong moment natin, kino-concave or binabaluktot niya yung beam natin ng sad face. So, pinapalungkot niya yung beam natin. That is the reason kung bakit negative yung value ng MB natin.